What is up, large data bankers? Welcome back to another episode of Large Data Bank. It's good to see you guys. Happy weekend, happy Friday. We're synth waving. I have to say that the synth wave, it's a good intro stream hype music. It's high energy, you know? It really makes you want to crush some code. But it's been a pretty good week, you guys. It's been intense of a week. Let me tell you, my gosh, there's been a lot going on in life. It's been working stuff has been going on. Life stuff has been going on. My girlfriend's out of town in Chicago right now, so I've got an empty house. But people are in town, they're visiting, so I want to go say hi to them and stuff like that. It's nice, you know, summer's kind of ending. Oh my God, and obviously what happened this week, which was super crazy, you guys, was that there was that whole hurricane situation. Not so sure if you saw what happened in New York City with the old hurricane, but it was absolutely out of control. Bad. It was bad. There was flooding. There was insanity. I posted a few pictures of Prospect Park after the flood, and it was like draining out, you know, like a river coming out of the park for like all day. It was nuts. Luckily, my neighborhood didn't get too badly affected, but my girlfriend's dad's place had 18 inches of water in the basement. I don't think they had any stuff in there, but like, damn. It's pretty crazy. I never really expected that to happen to New York City, but I guess that's just what climate change does. You know what I mean? It does the unexpected. It does the unexpected. So pretty wild stuff, and I think a lot of people had worse things happen to them. Thankfully, that wasn't me, but geez, it's intense. New York City, it's got to up its game. You know, it's got to figure out that drainage, figure out what to do about, you know, 6 inches of rain in 6 hours or whatever it was. It's probably not going to stop this year, is my guess. But anyway, that's that. Nothing too bad happened to me, luckily. Haratalk was at Spring 1. That is cool. That is cool. MD Layer, hello, by the way. Thank you for stopping in and view botting for me. That is very kind. Data Dev, hello. So Spring 1's, that's the spring conference, right? That's the Java conference, the spring conference. People like that, right? I've heard some good things about the spring one, but I've never gone myself, to be honest. It's a big one, right? Like a lot of things going on at Spring 1. So that's kind of what's been going on with me. Busy at work, remote. Oh, that's right. Yeah, we had like a talk at it or something like that, right? Yeah, I think we were going to maybe do one talk there or something like that. That's pretty cool. It is pretty cool. Someone was doing a workshop. Okay, got it. An iPad. Hell yeah, we love to give away iPads, I guess. That's the way to attract people, you know? You got to give away free electronics, I guess. I don't know exactly. I gotta get a new wire for my headphones because this one's like, it's getting flaky. It's like one ear keeps going in and out. It's kind of weird. I've had it not that long, maybe like a year, and it is a little flaky. I don't know what's the deal with that. It's just the wire though. I tested, like I unplugged this part, plug it into this part works, this part doesn't anymore, you know. Now it's working fine, but I had to like tweak the wire. It's pretty irritating. But yeah, so that stuff happened, and some other personal stuff happened. Exciting things. Maybe I'll keep that under wraps for now because I don't want to jinx it. I don't want to jinx this thing that's happening to me. But hopefully some good news in the future, in the near future, personal wise. Time to get the old soldering iron out. Yeah, I don't know exactly if that would be effective because you'd have to cut through the wire, you know, like, and I don't even know what you would do, but I don't think that it would work. It's the wire. It's definitely the wire. It's like there's a certain spot in the wire that you can kind of like pinch and squeeze, and then eventually it'll like either work or not work. So the connection, yeah, maybe, but yeah. So that's what's up, honestly. I had a couple of ideas for today, but nothing super concrete. The wire seems trivial compared to a distributed database. I mean, in the grand scheme of things, maybe, but yeah, if you had to build one from scratch, that would be tough. You know, that would be like you guys ever seen those videos that are like, I made a sandwich from scratch or whatever? This is kind of like, it feels kind of like that. You know, I don't know how to make a forge. Could be a good project though, forge making. I have my friend's car, so I've been kind of driving around doing random stuff. Got it for like 5 weeks. I went over to my parents' house this morning and helped them get rid of a bunch of stuff, which was kind of nice. They have like a stuff problem, a little bit of a stuff problem. And so I like, if they ever come to me and say, is there a chance you can help me get rid of some stuff? I will jump at that opportunity because I want nothing more than to help them with their stuff problem. I don't know if you guys have parents with stuff problems, but it's a thing. So I drove over there. We loaded up the car with some stuff and we brought it to the Salvation Army. And then I went home. So that's that. I don't exactly know what the Salvation Army does with most of the stuff that they get. I try not to think about it because I feel like a lot of it probably ends up in the dump anyway. But at least they might find a use for it with someone else. That's the hope, right? Other people can use the unwanted stuff. The reuse, reduce, reuse, recycle. Reuse. It's the reuse, right? Or is it the recycle? I'm not sure. I think it's somewhere in between. Reduce, reuse. So Craigslist free. The thing about parents with the stuff problem and Craigslist free is that this stuff, this isn't like item by item stuff. We're talking about bulk stuff. If you went item by item through the stuff, there would be no chance you would ever get through it. It's bulk. It's kind of like a bulk problem. We're talking like thinking in cubic meters. Once you start thinking about cubic meters, then it gets a little bit different. Even a stoop sale, I just don't know. I think it's bulk. I've given them some thoughts about what I would do strategy wise, and I think the strategy has to be sort and bulk donate to the right places, you know. But it's their stuff. That's the truth. I can't control them. I can only suggest, and I can't even suggest, right? Because it's touchy. It's hard, I think, if you have a stuff problem to get help with it, because it's your stuff. Anyway, that's depressing. But the point is that I helped them and it felt good. I had a few ideas for today. Basically, what I think we're going to be doing is getting back into the world. We've been circling around the lookup join world for the past several weeks, right? We've been doing the distributed lookup join stuff. We've been doing the vectorized index join stuff. I think I want to play around with seeing if I can expand the scope of times that the index join operator can be used. And I want to see if I can add the case called lookup join where columns are key to the list of things that we can vectorize. I think that's going to be my little project for today. The project we've been working on with this distributed lookup join thing is good. And I think it's something. It's like a crystal that I want to keep expanding on, but it's going to take time to convince people that it's the right direction. And it's going to take time for some other sort of unrelated infrastructural improvements. So, you know, it's a start of a conversation. That's what that work represents. It's not going to get merged for the time being, but definitely the start of a conversation. Hello, Halton Catch and Lieutenant Junior. Yeah, the software category. It's the dream. It's the dream. It's pretty cool. To be honest, it's just the same as the science and technology category, except it doesn't have the ducks, why do those ducks exist? Nobody knows. It doesn't have the ducks. It doesn't have NASA with 30,000 viewers occasionally, but that doesn't matter. That's pretty cool. And it doesn't have the like game, what is it called? GPU watcher price list viewbot things, which were sketchy. I don't know. I mean, honestly, the science and technology category, it was like coders and then like junk. So I like that they made a new category for just the coders. It feels a little bit better. Don't have to compete with the dash ducks, which I don't know, man. Anyway, so that's the plan. This is the plan. I think what I'm going to do is I'm going to start by filing an issue. Let me see if we even have an issue for vectorized lookup join. Oh yeah, the earthquakes. I forgot about the earthquakes. The weird thing about the earthquakes though, Peak, is that earthquake channel, it's not just earthquake watcher. It's also this like super weird right-wing commentator dude who will like talk about it. Just talk about like junk on his channel. It's insane. It's definitely not just Earthquake Watch, which would be like whatever. It's like this guy's weird radio platform as well. Your staycation starts today, off work till the 13th. That's awesome. No, yeah, it's weird. It's like this underground right-wing radio channel. It's really random. I only found out because one time I raided it after my stream, and I was really embarrassed because the guy started to talk about insane, weird stuff. Off work to the 13th. That's pretty good. That's a good long time to be off of work. What are you gonna do? Do you have some plans? So I want to see if there's an issue just for generalized lookup joins in being vectorized. Isn't this done? I'm confused. Oh, this was a stepping stone. The remaining work, number 2 in Rebecca's list above. So what's the remaining list? Okay. Okay. Costing for the vectorized engine, worst plans with stats, suboptimal, blah, blah, blah. Support for joins of columns of different types. It doesn't really seem like we have an issue for this vectorized support. Support all aggregate functions. Nothing too crazy. Outdoors. Plenty of restaurants. That's awesome. Hashing window partitioner. Should we... Oh God. We could just close this in favor of this since that's the only remaining task. I just want to find, I thought that there was this big issue that was like, what are the remaining operators that we don't support in the vectorized engine? And there's this. But where is the one where it's like, what if I search for label a SQL vec? I guess we don't, I guess we just must not have an issue for it. Okay, well, we'll just make one. So let's see here. Exec, I guess it's called call exec, add support for lookup join in vectorized engine. We recently added support for index join in the vectorized engine. In. See if I can find the exact PR here. $67,450. 67,450. And saw significant performance gains. This issue tracks adding support for lookup join, which we'd expect to see to provide similar performance gains. We trying to think, we probably want to put a couple of checkboxes or something like that, because there's a few different types of lookup join that we'd want to support, probably. Just realized I have my text messages up. Should close that, probably. Okay. I'm really surprised that we don't already have an issue for this, but I'm just going to open this, and if somebody sees it and it's a duplicate, they'll just close it. There are a few. I also need to open my Goland here. Well, I'll just leave it like this. So a SQL vec queries. So I just want to kind of go and see the different types of join reader. So the join reader, of course, is this operator we've been working on for the last couple of streams. We've been looking at distributing it, right? But it, just in the execution sense, it has a few different modes. It's got this index join mode, which we can already vectorize, which we use when we're joining a secondary index when it's primary index. And we've got a few different modes on top of that. What's up, Haney Copes? How's it going? How is it going with you? Right, so we can either be an index join or a lookup join, and we can additionally be a few different categories of lookup join. We can kind of be the case where lookup columns are key. So what that basically means is, so a lookup join is a kind of nested loop join, right? And let me open up my terminal. Sorry, I feel like I forgot to open my programs before starting the stream. A classic mistake. Check out master. Base. Let's make a new branch for this, maybe. Vectorized LJ. And let me open this up to be full screen, and we can make cockroach demo here. So of course, a lookup join is where we're doing a lookup per input row between two tables, right? So if we say create table A in primary key, create table B in primary key, C int or something, and we said select star from A, join B, where A is equal to 3 and B is equal, right? I guess we want to say A join B on A.A equals B.A, where A is equal to 3. And look at the explain here. What am I doing wrong here? Oh, I don't have a B.A. I just have a B.B. Okay, so it's choosing a merge join here, but we can just force a lookup join for the sake of comparison. I said inner lookup join B. What this is doing is it's going to scan over A, find all the rows where A is equal to 3, and then it's going to, for every input row, of course, this is sort of silly. We should maybe remove the restriction here. So now it's going to say for every input row, for every row in A, do a little lookup into B for each value of A that it finds, constraining B on the B side. And in this case, there's a special property of this join because if you go to the table definition here, you can see that B has a primary key of B. And this means that every time, for every value of B that we might be looking up, we're guaranteed that there only is going to be a single row in the B table for that value of B. So that's a very special property, and that property is called lookup join columns are key. And what this special property lets us do is very much simplify the algorithm that we use for all of this stuff. Just like index join, you know that there's going to be a single row per input. You can also expect that there's going to be a single row per input in lookup join where columns are key. The only difference is that, I guess with lookup join where columns are key, you might get 0 rows. So that is a small difference. Index join, there's always going to be exactly 1 row since there's always referential integrity between a primary index and a secondary index, but there's not always referential integrity between 2 arbitrary tables, even if the columns are key. So that's a small difference that we'll have to kind of look at making a change for, I guess. Hello, Nikon. This week, I would like to say thank you for this cockroach dashboard to help me find out a slow query that was running without an index. That is excellent. I will pass that feedback on to the team that works on it. I'm sure they'll be thrilled to hear it. That is very, very cool stuff. I'm gonna just screenshot this just to commemorate the moment, you know? But that's really cool. Really good stuff. So, Haney Copes, what we're going to be working on is trying to make that operation I was just describing, that special type of lookup join, more efficient. There's kind of 2 modes of execution in Cockroach. There's the non-vectorized mode and there's the vectorized mode. And so the idea of this project is to see if we can teach the vectorized mode to know how to do this simple case of lookup join where columns are key. So the other thing that I was actually doing though is I wanted to make this issue a little bit better, where we're talking about, you know, what we want to get done in this issue. There's like a few items that I think we should do. Marilia, did you see Nikon's comment? I thought Nikon's comment was nice. So, right. I think what we want to do, there's this notion of strategy that we have in this code base that I'm trying to remember. Yes, good. Marilia works on that stuff. So, yeah, there you go. You were summoned. You were summoned. Right. So look at these strategies. There's a few strategies. There's an ordering strategy. There's a no ordering strategy. And there's an index join strategy. The index join strategy we're going to ignore because we've already played with it. So this is Goland. It's actually not a cockroach specific IDE, but that'd be pretty cool. Or I guess I should say IDE. And so let's take a look at these 2 different strategies. This no ordering strategy is used when the join rows do not need to be produced in input row order. Cool. And the ordering strategy is when the joined rows do need to be produced in input row order. And I suppose that, is this even a good categorization of the things that need to be doing? I suppose I could start by saying there are a few modes of lookup join to add support for. I'll just say lookup joins when columns are key. Lookup joins that need to maintain their input and lookup joins that don't need to maintain their input. And I don't exactly know if that's the right set of things. There are quite a few more complex things that this lookup join processor does that I don't even really know about. There's something where we use like an expression to do the lookup. You see this? There's remote lookup expr. There's lookup expr. And I think that these cases we probably want to also separate. So lookup expr is used when the lookup condition is more complicated than a single equality between input columns and index columns. And this was added this year. Lookup joins with multiple spans. And then there's remote lookup expr, which is set if this is a locality optimized lookup join where we're doing local lookups and then also remote lookups afterwards if we can't find them. Something like that, right? So I feel like it would probably be reasonable to separate that into another case as well. But I'm not actually really sure. Yeah, I think so. So you see how, so basically, okay, the way that index join works, the simple case where there's always just one row per input row where we're joining a secondary index to a primary index. In that case, we're always generating the spans for the remote side by simply concatenating together the encodings of several columns in the input table. So very, very simple. And that's how the current implementation of the vectorized index join works. If we go look at that thing. If we go look at this thing, we have something called a span assembler. And a span assembler is going to take a batch of input. It's going to take several encoders, which are operators that take a particular column and turn it into bytes. And it's going to run each of those encoders and then output the whole thing as a big old byte slice. So that's kind of what the purpose of it is doing. But there is no kind of functionality for adding an expression in there. I suppose there could be, but definitely not yet. And so what I'm thinking is that anytime that we have that extra complicated functionality, we probably want to make a separate operator for it. Since one of the principles of the vectorized engine is that each operator is kind of hyper specific to the thing that it's doing. So if sometimes it does an expression and sometimes it doesn't, that's usually a good reason to say that there should be an operator variant as opposed to a big if condition. Because as we know, if conditions in tight loops, they really slow them down. So we really like to pre-calculate the things that we're going to do and set them up ahead of time so that during execution, you don't actually ever have to do any ifs. You're just really running tight code that somebody could have written specific for the query that you're running. That's kind of the idea of vectorize, one of them. So I'm kind of thinking that up here, I should say lookup joins that run expressions to generate their spans. It's hard to know exactly what kind of factorization we'd like to make. Factorization would be ideal inside of vectorized, since each of these modes, since some of these modes can be mixed and matched. I suppose there's also lookup joins, locality optimized lookup joins. And there's also inequality lookup joins, right? Isn't there some kind of inequality thing? Maybe not. I thought there was. I thought that's what there was like a recent change. What is this change? Range-based lookup join spans. Range-based, we can say. Range-based lookup joins. I'm going to just write a quick comment. I thought there was an issue for this, but I couldn't find it. Feel free to close this if it's a duplicate. So I think the next step is for us to go ahead and take a look at the plan conditions for this old index join vectorized thing. Okay, Haney Copes, thanks for stopping by. It was great to see you. Good luck with your programming. I hope you stop by again. So I think what we're going to do is look up at, what's it called? Yo, bro, Honster. Oh, I've got to update my project, don't I? Commands, edit, project, adding support for lookup joins where columns are key to vectorized engine. I was thankfully able to stay safe during the flooding. I talked about that a bit earlier, but luckily my neighborhood wasn't too badly hit. Some of my neighbors just a couple blocks south did have water in their basement. They had to mop it, but I think it was minor. My girlfriend's dad had 18 inches of water in his basement in Brooklyn Heights, which is pretty brutal. But I don't think they had too much stuff down there, but still, that's got to be pretty bad. And coworker had 6 inches of water in his basement in Park Slope. I mean, Park Slope, like you'd think that Park Slope would be fine since it's on a hill and high up, but apparently not. Apparently Park Slope was pretty badly hit, so it's crazy, man. I definitely did not expect it to be so bad here in New York, but it was. So there you go. Yeah, I think, I don't know. I think some people in Westchester County also got some pretty bad situations. A lot of basement water. That's what I'm hearing. And yeah, I think there were some more tragic things that happened in New York as well, but thankfully, didn't happen to any people that I know. But climate change, man, it's a bitch. It'll get ya. It will get ya. So yes. So right, what we want to do is look at what is it called? I feel like the more like forget the names of files more and more right now. Flow setup flow, vectorized flow, something like this, right? Okay, this is going to be looking good. Vectorized flow creator. What you really want to do is figure out what the logic is for deciding that you're allowed to plan an index join in vectorized, and then we're going to extend that. That's the first thing we're going to do. It was great to see you, by the way, bro Hanser. That was it was fun. Glad you stopped by. Are you back in California now, or are you still? Oh yeah, is this the weekend that they were going to have that festival thing? Are you still? Did that get canceled? Is that still going on? I hope they didn't cancel it. Okay, that's good. Yeah, fingers crossed. Man, that's going to be a big fun time. What is it called again? Is it Izu? Izu you're going to? Is there like a band that you're particularly excited to see? Do they even call them bands? Or are they just like acts? artists. Artists. Of course. Tiesto I've heard of. Tiesto is big, right? The other ones I haven't heard of. Illenium sounds cool though. Setup flow. Where's just the like, it's called like new call operator. Here we go. Execplan.go. How could I forget? How could I forget that? How could I forget that? What's up, Pratik? Good to see you. So here is the question. Here is the question.
Computers hooked into over 1,000 data banks throughout the world.
If we see that we have a join reader spec, that means that we're either going to be planning an index join or a lookup join. This is the check to make sure that we're not planning a lookup join. Fridays seem like Mondays, dude? No, that is terrible. That's the opposite of what you want. That is absolutely the opposite of what you want. Okay, so if the lookup columns are not equal to nil and the lookup expert is empty, let's take a look at the definition of this thing again. So if empty, the start of the input stream schema is assumed to match the index columns. If it's populated, the join reader will perform a lookup join, and the internal columns will be the concatenation of the input stream columns followed by the table columns. Database position where you don't have to be on call. Those exist, I think. Yeah. They exist. You just have to, pick, you know, part of the database that isn't in production or something. There's a few. There you can find things like that. They might be temporary, but they exist. So this is the dream. You want lookup columns or key. It's kind of like, oh my gosh. And there's also, of course, inner versus left outer, right? Should edit this to say left outer joins. Yeah, that's, you know, that's not, you're not wrong. You're not wrong. Work at a research company. Stay in that ivory tower. No on call in the ivory tower. So I think what we would want to do here is say, in our exec plan, we could have a new case. We could have the case of if core.joinReader.lookupColumns is not equal to nil. Why don't we say this? We'll say something like this. If the lookup expr is empty, we definitely don't support it. So we're going to say lookup join reader with exprs. Ivory towers. I mean, I'm talking about academia, baby. You know it. That's the ivory tower I'm talking about. Or tiny small startups or new companies. Yep. Yep. So if the lookup columns are not equal to nil, then we have some cases, and we can say if core.joinReader dot I guess we can just say if core.joinReader.lookupColumns are key and core.joinReader dot. Yeah, we definitely don't want this left join with paired joiner business. This is definitely wrong. So we need to maybe add this thing as well. Paired joiners. So if it's lookup columns are key and there's no left joiner paired joiner and core dot join reader dot maintain ordering.
Computers hooked into over 1,000 data banks throughout the world.
We can keep maintain ordering. The key question is the type. And we want to make sure that it's an inner join. Join type inner. So here is our special case. We can support a simple lookup join. So then the question is there a way that we can convince the index join code or something very close to it to support the lookup join? And I want to take a look at what our call index join is doing and see essentially the only difference that we have to do is we have to change the input column mapping so that we're making sure that we are generating the right spans, even though it's not an index join anymore. So that's task number 1. And then task number 2 is to make sure that we can handle the case in which we don't get back a result from the fetcher. Because unlike index join, it could be the case that there isn't a match for a particular table. So let's take an example. Create table. Oh, we already have our table. So we'll say insert into A values. We'll say insert into A, select star from generate series 1 through 100. Then we can say insert into B values. Well, I'll just do the same thing. Insert into B, select G plus 1 from generate series 1 through 100. But then I'm going to delete some of the values here. So I'll say delete from B, where B is equal to 5. So let's see what happens when we say select star from A, inner lookup join B on A.A equals B.B, where A.A is less than 11. So note that there's something interesting going on here, which is that we don't have an entry for 5. And that's true because there's no 5 entry in B, right? This is SQL joins. You familiar with that a little bit, maybe? So we can say, we can make it even tighter. A.A is greater than 3. And so we only have values for 4 and 6. Of course, who knows what happens in SQL where I change this to be a left outer lookup join? Anybody know the answer to this question? What's going to happen? Since we have all the values in these tables except for 5, what's the difference in our output? Pop quiz. Okay, forget lookup. Let's say we just look up like this. Left outer join. The lookup join is just a hint, and it's unnecessary. Hi, John Compy. What's up? You guys know this one. Yes, it's going to fill up with nulls on the left. So I guess technically it's filling up with nulls on the right, but that's okay. So left outer join means that if there's ever a row on the left side of the table that doesn't match the table on the right-hand side, we'll still include that row, but the right-hand side will be filled with nulls because it doesn't exist. Right outer join works the other way. It's so that if there's ever not a match on the left side, and there's a match on the right side, the left one will be filled with nulls. And full outer join gets both. So that's what left outer join is about. Outer joins are like including rows in a join when there's no match. That's what the idea is there. So anyway, coming back to the inner lookup join though. In this case, we don't have the 5 because it's not there. So the key is that in index join, as opposed to lookup join, that can never happen. So there's no case for it, and I'm guessing that the whole thing will blow up if that happens. So I want to check out what happens. I want to check out what happens. Oh, and we do actually have a maintain ordering. That's actually pretty neat. So we do have a maintain ordering. So we can support that case as well. So this is the key thing. Index joins will always return exactly one output row per input row, right? So what happens? Constructing spans. Get spans. So here are our spans. We sort our spans, and then we run our scan. So the key is that there is a pretty major difference between what index join does and what lookup join will have to do. And the reason for that is that we actually have to do the join. So actually this is going to be quite a bit different, unfortunately for us. Because with index join, you actually just throw away everything on the left side, I think. Is that right? I think that's what we do. We don't even use the values on the left side. We just chuck them out. And lookup join is going to be quite different. It's not going to chuck anything out. It's going to keep everything on both sides and stitch them together. So I think what we'll need to do here is add a new file with a whole new operator. It's a little bit weird because, to be honest, this code is just so similar. So similar to what we'll want. You know, most of everything is the same here. The only difference is what happens in the scanning phase, right? I mean, let's think about it. It's actually, it's a little bit even different than that, because the unfortunate truth is that when we run next batch here, we don't have the information about which rows, which spans came back with information and which spans didn't. So we have to find some way of hooking up the spans that we found, or the rows that we found, with the spans that emitted them. And that isn't actually something that is supported right now, I don't think. Which is a little bit unfortunate for us, I would say. In the ideal world, this whole code, it would give us back a batch, and the batch would also somehow include the spans that generated each value or something like that. Because without that, you have to do something very inefficient, which is to maintain a map. You have to maintain a map between the input row. What do you even have to do? What does the normal join reader do, actually? I don't even know. So what does the normal join reader do in this case? It's got to maintain a map between the input row and... Oh, you know what it probably does? Is it probably maintains a map of the lookup columns, right? That would make sense. The left-hand side is looking up things by concatenating together a couple of columns from the input and then getting back any data from the output. And then you can actually parse the output. Since the output's going to contain those two same keys that you used to look them up with, and stitch them together and then compare them in a hash table. But it's really extremely inefficient, and that's sad for us. So probably there's a better way. All right, where's this? There's got to be some map that we do. Perform lookup, right? Key to input row indexes. This is exactly the sort of thing that I'm talking about. So key to input row indexes is a map that maps a concatenated key to the indexes of the input or the output? Input, I guess. It says input row indexes. It maps a key, the lookup key, to the indexes of the input rows that generated that particular thing. I don't know why it's a multi-map exactly. That's kind of odd. Oh, maybe it's because each input row could generate the same output row, couldn't it? So that's a thing. But yeah, I mean, having to maintain a hash map for this, it does feel really, really inefficient, especially since in the vectorized engine, doing hash tables is difficult and painful. And I would prefer, if I could possibly avoid it, to not have to do it that way. And to be honest, there should be a way to make that happen, right? I mean, technically, we have all the information that we need. We just throw it away, right? Because the left side, we generate these spans for the lookups, and the code that goes to the remote, to the data, to find data per span, every time it comes back with data, it should still know the span that generated it, because we do things sort of one at a time. And so in that moment where it's getting back a response for a particular input span, it should be able to like associate that all together and hand it back all the way up to the top. And then we should be able to use that information to stitch things back together afterwards. But you know, actually this reminds me of something, which is that there's this ongoing thing. There's this ongoing thing called the streamer. There's work ongoing on something called the streamer. Let me see if I can find it. And the streamer is very interesting. What it gives us, it's going to give us back. The streamer is a more advanced and better way to do lookups of data for spans. It's going to be the future of all of this stuff, where we're taking a span and sending it out and finding what's inside of it. And it's the future because it's going to be more efficient and more concurrent, as opposed to the current thing, which is a little bit awkward and difficult to use and has some issues with memory management. But I think that there was some provision in this thing for, yeah, you see this? Keys. So in queue, let's take a look at this interface. In queue dispatches multiple requests for execution. The only problem with this thing is that it doesn't exist yet, but it will. Results are delivered through the get results call. If keys is not nil, it needs to contain one ID for each request. Responses will reference that ID so that the client can associate them to the requests. This is the dream. This is really the dream, and we want this. Because you know what we can do, you guys, is we can use the indexes of the rows in the input batch that generated a particular span as the key. And then instead of having to do any kind of hash map or anything, we really just do a lookup by index, which is extremely efficient because you just have to use an array. So truth be told, I feel like we should wait for this unless there's a way to do something quick and easy, because without something like this, it's just so annoying and difficult. I suppose there's another alternative, maybe. Is there another alternative? Hey, Andrew. Are you going to unify lookup and index join, or are you going to make a new processor? Should you implement on top of the proposed API and let somebody implement it for you? Definitely possible. Definitely possible. I'm not sure if you caught what we were just chatting about, but ideally, we would want to have this interface around. It would make it very easy. And I think ideally, we probably wouldn't unify index and lookup join because they're just a little bit too different. You know, we've had some pretty good success with either using templating or just implementing similar but different operators separately in vectorized. So we'll probably end up doing that. I think on this particular stream, don't think I'm going to end up getting something working all the way end to end, and probably somebody else will end up writing this thing, if I had to be completely honest. But that's okay. You know, we're just playing around. We're seeing what we can do. We're seeing what we can do, which is, I think, a useful exercise to see what we can do. But I think one thing that's interesting that I would note is that if we had the streamer, then at this moment here, where we're doing this start scan business, we would also be including these indexes, right? We'd be including these indexes, and we'd sort the indexes along with the spans. We'd kind of sort them. We'd have a big structure that associates spans with indexes, and we'd have the sort key be the span, but we'd keep the indexes, we'd allow them to be shuffled along with the spans. And we just pass those indexes right into this. And then down here, where we get out the result of this fetcher, then we're going to be happy because, wait a minute, this is the wrong code. We want to be looking at the index join code. What I meant to say was here, where we get this batch thing out of this row fetcher thing. This is going to give us back in some way, shape, or form those indexes. And then instead of just returning this whole batch, we'll do like a little, we could probably even insert one of these pre-existing, there's something called like a simple projection operator or something like that, or there's like a union operator maybe. There's like some operator that takes two batches and puts them together side to side. And I wonder if we could use that thing after selecting out the ones on the left that aren't matched using the selection vector. That's really thinking with vectorize, right? You know, let's say we get back a bunch of results and the bunch of results are missing several indexes. I think what we do to be super cool in vectorized E is that we would we would actually just use those keys. Oh my God, you know what's actually really cool is that this thing is going to give us back this list of keys in a certain order. We're going to resort everything so that it's back to the existing. Actually, I don't know what this is going to give us back. In order mode, responses will be delivered in requests order. So I'm not quite sure what would happen here, but the point is that I think what we would end up doing is resorting these keys back to the correct like ordinal order, and then we could just use this thing as the selection vector, right? On the left side, and then we would send all of the data to like a union operator with the fresh right side batch that we just got back, and then lookup join would be finished, which would be actually really sweet. At least in this very simple case, which is called, you know, inner lookup join where columns are key. It could be that like that little optimization isn't worth it because other things are going to be quite different, but I don't actually really know. Yeah. In the meantime, to be honest, I feel like one approach could be like edit the row fetcher and give it a similar interface as this like keys input output mapper thing. But I feel like if I do that, the work will be wasted because the existence of this streamer thing will happen in relatively short order. So yeah. So yeah, I don't know what that tells me. Frankly, I don't know what that tells me. I suppose what I could do yeah, that's a good point. We could assume that we had a streamer. We certainly could assume that we have a streamer. We could assume that we have a streamer. Then we'd at least learn a little bit, right? We would learn some things. We would certainly learn some things. We would learn about, I mean, truth be told, actually, one thing that I have a question about is, how far did Yahor get? Did he end up working on changing the C fetcher? Doesn't look like he did. So you could conceivably imagine. I mean, the truth is actually that this interface is gonna have to change anyway, isn't it? Because this C fetcher thing is not gonna go away. And you're gonna have to be able to pass in keys along with the spans. So realistically, wait, does that already exist? Checked in somewhere? No. Oh, you're saying for the interface. I think what I'm saying is that no matter what we do with the streamer, we're always going to have to end up adding to start scan another slice of keys, right? To match. To match the interface to the streamer itself, right? AKA this guy, right? It's just a slice of integers. So I think what we would always need to do here is say, key is slice of integers, and these guys would gain. We could just pass nil for now or something like that. Right? That's what I'm thinking. And then the nice thing is that we could conceivably say for this invocation, we could actually start passing in the keys that we desire in this case, which I suppose would be something like this, right? We would say spans equals spans. We would then associate all the spans with the indexes, right? So we would make a new slice. We'd say keys is equal to make int len spans. And we'd say for I in range keys of I is equal to I. And then we would say, instead of doing sort.sort, we'd say sort.slice. Then we'd pass in. Isn't there where's the thing where you implement swap? We need to implement swap here. I guess you have to use the interface thing then. Presumably, right? Data.less and data.swap. Wait a minute. So this thing already has a swap, is what you're saying to me. It does. Okay. So that's fine. I think what we'll do is just make a new data type here in our little guy. We'll say like
The data bank's too big. I have to narrow down the search.
we'll say something like sortable indexed spans. We'll say roachpb.spans, and then it'll also have a list of keys, right? And then we, on top of this, implement sort.interface. Oh, because it's not. I can just. This is annoying. The ID support for that not quite as good as I was expecting, but that is just okay. Sort.interface. We'll just grab this stuff, stick it over here. We'll call this index spans, and here we're gonna say return length of a.spans. For swap, we'll say instead of just swapping a.spans, we'll also be swapping a.keys. So we'll say a.spans, 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 and then a.keys of I, a.keys of j is equal to a.keys of j, a.keys of I. Okay, and then for less, we'll actually literally just use this same thing. So it's going to be a.spans of I dot key compare a dot spans of j dot key. Okay, so then we're going to write a quick comment, and this can actually be lowercase. It doesn't need to be uppercase because we're not exporting it. So index spans is a small wrapper on top of roach pb.spans that additionally tracks an index key. I guess this should really be called, we'll just call this indices. Additionally tracks some integer indices, 1 per span. Sorting the index spans will sort both the spans themselves and also their associated indices. By, I guess we'll sort, let's see. The index spans are sorted by their underlying spans. How do you say this? Sorted by the roach pb.spans, but the indices are sorted along, sorted as well. How do you say that? Are sorted in the same way, something like that. Whatever. Thanks for the follows, guys. Okay, so that's that. Then this is in the wrong file, of course. This is in the wrong file. Actually, I suppose what we could do is say, we could conceivably say that we're actually going to send in, instead of sending in a.spans, we'll send in the whole sorted thing, maybe not necessary. Anyway, what we wanted to do it was put it here. Okay. So we're gonna say index spans is equal to index spans fill all fields. The spans are going to be the spans, and the indices are going to be the keys. And then we're going to say sort.sort of indexed spans. Okay, so then what we have is something pretty neat. We have the spans are sorted. And then in addition, we have these keys, which are either sorted if they need to be or not sorted if they're not. But it doesn't matter if they're not sorted. That's just as good because the streamer is going to use them just the same, sorted or not. And we're going to be using these indices to associate the returned rows with the spans that generated them very cheaply, since we can just look right up. The only confusing thing here are we gonna have to unsort? Is that how this is gonna work? We're gonna do we unsort? I think we have to unsort, right? No, we don't have to unsort because we're not gonna be looking back up into the spans array. We're just going to be looking up back into the input batch. What does consume batch do? It really sounds like the batch gets destroyed. Unsort? Ever heard of unsorting? Unsorting is the operation of putting things back the way that they used to be, which we can do because we do have those keys, which are, they started as ordinals. We could just resort by the ordinals, but I don't think we actually need to do that at all. Consume batch. I don't think this batch really gets consumed at all, does it? So I think we're fine there. I think what we need to do yeah, so okay, so we pass these keys in, we get the keys back. That's so the next key thing, haha, is that we need to find a way to thread these keys back out of this row fetcher interface somehow. And I don't exactly know how we're going to do that. Do we append them to the batch? Is that what we do? It's going to be tricky. The C fetcher is complicated, as we all know. Streamer or no streamer? This is going to be tricky. Why is sorting involved for a lookup join? Excellent question. So the reason is that it can be more efficient to not require that the input ordering is the order in which we look up things at all from the KV part of the database. And so depending on whether we need to maintain the ordering of the output, by default, so in this example query here, nobody cares what the output ordering of this thing is going to be at all, because nobody's really, it just doesn't matter. In SQL, unless you have an order by or like a cascade of order bys where things need each other's orders, then the engine is allowed to return results in whatever order that it wishes. And so in the case where we do not care about the output ordering, then what we like to do is sort the spans. And the spans meaning like the keys that we're looking up in the other table, because it's more efficient for the underlying code to do things that way. It's allowed to do some trickery. It can group the spans in an efficient way and not have to like shuffle them all around, finding the right ranges where things are getting sent to. Kind of range reads, it's not exactly that, I don't think. I don't think that anywhere is actually coalescing the points into ranges, although it might, but I don't think it does at this particular level. That happens, but at a higher level. I think what it really is just that it's much more efficient to chunk up the spans by the range that we're going to be sending them to in the CockroachDB sense of the word range than having to like do a hash map or something like that. So I think that's the reason. Not 100% sure, but I think that's the reason. We can find out, actually. I'm sort of curious. This allows lower layers to optimize iteration over the data. Note that lookup rows are output unchanged in the retrieval order, so it's not safe to do this when maintain ordering is true. Maintain ordering. Indexed spans. Where do we use that information, I wonder? I don't know. I don't know. Ah. Oh, yeah. And it has to do with this limiting stuff. It's complicated. The answer is that it's complicated. Basically, I mean, to be honest, this whole thing that I was talking about earlier, the streamer, is going to be a way to improve a lot of this junk. The streamer is a lot smarter than the way that we're currently doing this thing where we're trying to keep memory limits on parallel reads. It's complicated to do that for various reasons. So the streamer is a new interface that we're implementing to do better. And to be honest, it actually might end up rendering some of this irrelevant. It might end up rendering this sort irrelevant, but we'll still need the keys. So like these keys. In order at, oh, this isn't actually code. It's just this is just pseudocode, and it's saying that it's going to be an enum with one of two values. It's not actually code. That'd be cool though. Oh damn, yeah, wouldn't that be nice? Cool extension to Go, or an uncool extension to Go. So anyway, even if we do have the streamer, my point is that this cfetcher thing, it's still going to need to figure out. Going to need to figure out a way to return those keys, and that's gonna be a little bit tricky, potentially. potentially. I think what we're going to want to do here is add another column to the output with a special index that nobody else cares about. Maybe. Maybe. The other option is that next batch could, maybe you call next batch and you also call like some other thing and it gives you back another index on the side of the batch or something. I don't know. I mean, you could also conceivably just return another value here. We could try that for now, maybe, just since we're playing around. So we could say keys int. Gotta call this something else. It's already used. This is like the longest method ever. But, you know, sometimes that just happens. Sometimes that just happens. If you're programming. Okay, so that's that. Ret keys nil, emit last batch. Okay, the key spots that we're gonna need to change are when we emit a batch. And the thing that we're gonna need to do is keep track for every column, for every row in every batch, which span it got emitted from, right? I guess in the streamer though, what we're gonna get is a new thing, get results result, and a result is gonna have a key, right? So this is the new thing that we're gonna have one day. And so we can imagine that when we say next KV here, this thing is gonna give us back a key. It's gonna give us back a key. It's gonna give us back several keys, potentially, which is odd, but you know, that's fine. That is fine. So is there a way that we could implement that exact interface now? I'm not sure. It might be annoying. Could be annoying. A lot of calls to this baby. A lot of state to keep track of. It may not be worth it to implement it in the current interface. Maybe we just wait for the streamer. Maybe we just wait for the streamer. Batch response. So each batch response comes from a single batch request. So this is the right level at which we can return things. But we don't currently have information about whether these things came back from a new span or not, I don't think. Right? Right. Because this guy, of course, can take multiple spans in the input, doesn't it? Sure does. List of spans. And when it gives us stuff back, it does not tell us which input span it's getting us stuff back from at all. It does have pop batch. I feel like messing with this stuff is always annoying. Always extremely annoying. A ridge span. So it does have some notion of this, right? Where does a ridge span end up going to? It's used for get response. I see. So I think what we could do here is we could conceivably.
The data bank's too big. I have to narrow down the search. How are you going to do that? By guessing.
We could conceivably keep track also of the original length of these and subtract by the current length, and that's how we could get the index. And then instead of just returning t.rows in batch resp, we would also return that index. Would that work? I think that would work. Basically, I mean, I could just wait for this streamer thing, but I do think that all of these interfaces are going to have to change anyway, so maybe it's worth just implementing it all the way through in the current stuff. I don't think it's going to be too hard, honestly. A little bit brain bendy, but not that bad. I think all that we need to do is go, when we set request spans, we've also got to set up the number, the size. We've got to have a new value in here. We have to say a ridge, or n request, like a ridge request spans count. Ridge request spans count int is the number of spans that this batch fetcher was last initialized with. Okay. And then what we do is, okay, so let's think carefully. If we're popping off a request span, and we now have n-1 request spans. So let's say right now, how does this work? We started out with n of these things, and let's say this is the very first one. Then we just subtract. We subtract. So to get the original index into request spans, aka the key that we've passed in. Oh yeah, don't we need keys though? Hold on a minute. It's worse. We need to be remembering that people are going to be sending us this keys array. And we're just going to be popping off the keys in the same way that we're popping off the request spans. What's up, Enough Stuff? It feels new, shiny, and improved. Is it because of the beautiful new software and game development category? Is that the reason? That's the main change that I feel like has happened to the stream. I'm not so sure about any other changes recently, but maybe there was one. Maybe you haven't been around in a while. I don't know. Kind of curious, like what is the, yeah. Oh, you haven't seen her on Dunch Catch Things Friday afternoon. Okay, that's cool. Well, thanks for stopping by, buddy. It's good to see you. So I think what we're going to actually be doing here is when we set this thing up, we set this thing up, we actually also have to pass in a list of keys, right? Where is that done? I'm a bit confused where our constructor is that we actually use here, because it's not this guy. Is it this guy? New KV fetcher? Yeah. Here's this guy. What's up, Flask? How's it going? So I think the key is that we're going to have to pass in keys like this. Keys int. That's the thing. That's the ticket. So spans is going to get keys. And we actually do have keys because we are passing it in. So that's great. That is just fantastic. And when we do this here, we're going to be passing in keys like so. And we're going to be adding this to the signature. Just like so. Just like so. And the old collars are going to have to be updated as well, which is just fine. So this is going to be nil for keys. And this one's going to get updated too. Nil for keys. Yep. And then what we're going to do is when we set up our spans, we're also going to be setting up our keys, which is going to be just simple, very simple, not complicated. Keys, like this. And this doesn't exist for some reason. We're certainly going to need to add it. Keys int. Keys is a slice of integers that serve as keys into the spans list. Each returned set of data will include the key that's associated with the span that generated it, allowing callers to associate returned data with specific input spans without having to use an expensive bytes map. Yeah? Ba-ba-dum-bum. Cool. Okay, so that's very good. We're setting our keys, and then lower down, when we pop off our spans, we can also pop off our keys. And then we can return them in some way, shape, or form, and that's going to be just great. Just great. We're going to do it. Where are we going to do it? Oh, we can get rid of that count thing. We can get rid of this. This is not necessary. When we do this responses thing, ooh, is there some terrible trickiness with resume spans that we have to think about here, or what? It's very possible. I'm just going to put a fat to here, to Jordan. What do we do with keys when we get resume spans? So a resume span is generated when the data that we're asking for is bigger than the limit of data that we want to consume at the same time. And so this input spans are modified and given back to us as resume spans. That's what that means. And presumably it means that we'll have to edit our keys carefully, but we'll find out what we actually have to do here. I think, yeah, so fetch, where is, I don't know what to do here, to be honest. Need to think about it. Here's our responses. Where do we do, where is pop batch, this function. This is called next batch. So this actually happens, this calls fetch? Is that what it does? Yeah, I guess so. So in the simple case with no resume spans, what happens is that there's something about remaining batches. The purpose of this loop is to unpack the two-level batch structure that's returned from the KV layer. A particular batch request from batch will populate the f.responses field with one response per request. Batch response request from fetch with one response per request. Each response in the responses field itself can also have a list of batch responses. I see. So this guy, we're always going to be returning the same key. And I think the truth is that we're going to have to add yet another return parameter to this thing called key. We could also just make a new struct here. But what's the fun of that, huh? Right? Right? What's the fun of that? Do you know anything about Boolean expression trees indexing? Boolean expression trees indexing. No, I don't. What is that? I can imagine what a Boolean expression tree is, but I'm not so sure what a Boolean expression tree indexing is all about. I think I'm just going to add another return parameter since I'm hyper lazy like that. Well, should I do that? Ooh, what is this? A tree of Boolean predicates. It makes sense. I think I get it. I assume you're trying to work on them. Maybe you have a problem that you're trying to solve. It sounds like one of those algorithms-y things, right? One of those algorithms-y things. I think I'm going to make a new type to return from this thing, maybe. Type. Except does this thing implement an interface? Oh, it totally. Oh, no. It's going to have to change a bunch of crap. Well, that's fine. Maybe it's worth it, frankly. Maybe it's worth it. Maybe we should have something called type kv batch. Fetch response. And it's going to have okay bool. Oh yeah, you're totally right. Sorry, I don't have my my stream labels up. Should fix that. Stream labels. Totally forgot about the stream labels. Thanks for reminding me, Cyclo. Thank you also for the follow. Appreciate it, friend. It is important. I appreciate it. I do appreciate it. Thank you for mentioning it. You gotta have those. You gotta have that stream labels up. That's like a critical part of the interactive nature of the stream. Otherwise, it might just be a recording, right? That's the whole point. That is the entire point. It is not just a recording, right? That is the key. Okay, we're just gonna go for it. We're just gonna go for it. We're gonna edit these return types here. So it's gonna have an OK bool. It's gonna have a kv's roach pb dot key value. It's gonna have a batch response byte. it's going to have a key int. That's the latest thing we're adding. KV batch, well, KV batch fetcher response contains a response from the KV batch fetcher. This should be called more keys. More keys is true. There are more keys to fetch in the scan. Only one of KV's and batch response will be set. KV's, if set, is a slice of roach pb.keyValues the deserialized KV pairs that were fetched. Batch response, if set, is a packed byte slice containing the keys and values in the keys and values, whatever. Okay. Key is the key associated with the span that generated this response. What do you guys think? Do you think it's good practice in Go? If you're returning a return struct like this, should the return struct contain the error, or should it just be like, should I change this to be like response error, or should it just be response and then the response contains the error? I kind of think it should be response comma error because it's just like, I don't know, it feels weird to not have that error be top level. I think I'm gonna go with that. Yo, what's up? Costco was a madhouse, eh? Were you buying bulk mustard? Matt, maybe you'd have an opinion on this Go style point. Let's say you're returning a big old return struct, you know, to clean up your return signature. If you're doing that, is it better to include the error in the return parameter list or inside of this like response struct thing? I think this is better because it's just more canonical to always have that error. But I'm curious what you think. Separate? Yeah, I agree. It would be confusing, right? You're like, unpack this thing and look at the error. People would probably just like forget to look at it, honestly. A new Kirkland branded Islay Scotch. That's awesome. Kirkland branded Scotch. I mean, to be honest, that doesn't sound like it would be good, but I'm curious if you end up liking it, I guess. Isn't it normal to return the object in error as a tuple? Yeah, I think it is. I think the thing that was throwing me, I guess, was just the fact that we're making this response struct just to get around the fact that we have too many return parameters. But yeah, now that you mention it that way, you're totally right. That is just totally normal. They make a contract with a distillery, so it's the distillery's own product, but branded as Costco's Kirkland signature brand. That's funny. Rumored to be one of my favorite distilleries. Oh, that's cool. Which one? I'm not going to know it, but I'm curious. Kale Ela. Heated Scotchy goodness. I'm sure. Call Ela. There you go. I got one of them right. 1 out of 2. I'm batting 500. So if error not equal to nil, we can just return false, nil. I guess this is roach pb.keyValue. Then we just got to say if resp dot more keys, I guess I should call this more KVs, more KVs. The one time it makes sense to not return an error from failable methods is if you're doing the iterator pattern. Yeah, that makes sense. That makes sense. That does seem pretty standard. Otherwise, you need v error s dot next error not equal to nil, v error is equal to next. Yeah. I feel like we debated something like this on the stream like 9 months ago. You know, I think what we could do here is simplify a little bit. If error is not equal to nil or not resp dot more KVs, then we return like this. A little simpler. We set new span. Now the thing is that we're about to get a lot more. Oh, we don't even use this thing. Well, that's great. I think the main thing is that we want to change this to the key. Good luck, man. You too. Have a great long weekend. I'm sure they're going to love you. Okay. So the key is that we've got to say f.kvs is equal to resp.kvs. f.batch response is equal to f equals resp.batch response. Okay. So now that we've done that, we just need to go around this one. I don't think we really even care about this key thing in this case because we're not going to be using it here, frankly. Thanks for the follows, guys. Next batch. So this guy's got to return different thing. It's got to return heavy batch fetcher response. All right. We've got to go to txn kv fetcher and edit that thing now. Next batch. It says to return the new object called kv batch fetcher response. Bum, bum. So we're going to return response. It's going to contain batch response true, or batch response batch resp, more kvs true. And it's going to also this time include the current key, which we don't have recorded yet, but we're about to. And then down here, we're going to batch resp. We'll say var batch resp. Well, we'll say var ret. Batch resp. We've got to pull out our key here as well. This is an important point. So we're going to say f.cur key is equal to f.keys of 0. And then we're going to say f.keys is equal to f.keys everything but the first. Okay. And then we can say ret is equal to kv batch fetcher response. Key is equal to f.cur key. And we can say more kvs is equal to true. And then here, I guess we just say ret dot kvs, ret dot batch response is equal to, oh wait, t. We've got to somehow say ret dot rows, ret dot kvs is equal to t dot rows, basically. Yeah, I think this is right. So we'll copy this. We'll do the same thing here. Ret dot batch response. Then down here, we're going to say the same thing. Return ret. And we've got to populate the key, the kv, which is kind of weird. So we're going to say ret dot kvs is equal to like this. Yeah, okay. And then return ret nil. Otherwise, we're going to return, which we don't have. So we're going to got to do something like batch response, blah, blah, blah. More KVs, false, nil. Same thing here. All right. This is a jam. Absolute cat jam. Okay, so that's that. That is that. Now let's think carefully about resume spans. Does that do anything weird to us? Yeah, I don't understand what we do with resume spans at all, frankly. It's confusing. I think what we do I think what we do No, I don't know what we do. So each of the responses. Okay, I think I know what we do. I think I know what we do. Do I know what we do? I think what we need to do is have a new set of keys or something. We have to have a new set of keys, and we've got to associate, since we know exactly which input key is causing which resume span, we've got to associate each resume span with one of the input keys and have a new key slice that's used for all the resume spans, and then swap them out after we're done. It's terribly gross, and I hate it. I totally hate it to death. Hey, what's up, Ethrix? How's it going? How is it going? Yes, I was promoted to director. Pretty exciting stuff. Pretty exciting stuff. I've been good, though. I've been good. I have been good. We're just doing some programming. We're thinking a little bit about Memorial Day weekend, or not Memorial Day weekend, Labor Day weekend. That's what's coming up next, right? That's what's coming up next. So we're doing a short stream. We're gonna go chill after the stream with some folks, some friends. But yeah, long weekend. Love that. Thank you. I hope you're doing good too, man. Anything new with you? So I think we need to have a new list. Truly gross. Request spans versus spans, right? When do we set request spans? Talking about internships. Now you're wrapping up the internship? Or wrapping up school? Either way, congratulations to you too, my friend. Presumably you're talking about internships, right? Because the summer's almost over. Request spans, right? Just graduated. This is your last internship. Awesome. Congratulations. That's a big step forward. Big step forward. It's really cool. Do you know where you're gonna go? Are you gonna get a return offer from where you're working? Work somewhere else? So we need another keys array. Interning at Datadog, nice. I've got some friends who work there. I hear it's a pretty cool company. Pretty cool company. My friends work in the like stats world though. I know some data scientists at Datadog. I bet I know some engineers too, but mostly I know data scientists there. Oh yeah? What's the newest product? Database monitoring. Oh, nice. Oh, do you work with, doesn't Felix Geisendorfer work there? Felix Geisendorfer. Isn't he at Datadog? Yeah, he's a Datadog, right? Do you work with Felix? Smart guy, Felix. Rather smart fella. I know he does something to do with Go monitoring. Maybe it's not really database monitoring though. You've heard of him? New staff engineer. Yeah, we've chatted a little bit about PProf related stuff because he's focused on that, improving that for Go programs. So request spans. Is this what we keep updating, or is it? It's what we keep updating, right? Yeah, I think what we need to do is request spans and request keys. Request keys. Request keys is 1-to-1 with request spans. Just got paged, brah. No problem. Dominic, what's up, man? It's been forever. Good to see you. Yeah, the schedules have not been lining up. Absolutely. What have you been up to? Good stuff, I hope. Good stuff, I hope. So we copy our keys into the request keys, and then later we have to update. We've got to update our keys, right? Guess it's over here. F.keys is equal to F.keys of 0. Staring at monitors, waiting for interesting things to happen. That sounds just like a Radiohead song. Sounds just like a Radiohead song. So the way that this now works is what? The way that this now works is that for each resume span that we get back, we need to carefully associate Mike, the absolute unit. Welcome to the stream. What a name. What an absolute name of a unit. What a unit of a name. So I think what we do here is basically we say these responses is one-to-one with the request spans, right? So I think what we do here is basically say f dot keys is equal to append f dot keys, and then we have to pick out the ith key in the request key arrays or something. It's really quite sketchy, frankly, but I think this is correct. I guess we'll find out when we run all the tests. But I think that this is probably right. Okay, and then later, when we're looking through our keys, instead of looking at keys directly, we're going to look at request keys. Okay. And we've got to update request keys instead of just keys. Okay, I think this is basically going to be good. And the new thing is that we're returning back this cur key guy, which is going to allow us to associate every piece of return data with every piece of input data, which is really the dream. It's absolutely the dream. Absolutely the dream. So yes, given all that, what's our next step here? Our next step is that this guy is going to have to update as well. We've got all sorts of plumbing to do. All sorts of plumbing to do today. But at this moment, I think that we should be able to return our key because we've got f.key now. So we're gonna just add another parameter to this return thing because we're feeling lazy. Well, should I introduce? I don't really want to. I don't really want to do that. They're all sitting happy doing stuff. I'm just gonna introduce another parameter. Don't judge me. Don't judge me, stream. Don't judge me, chat. Okay, so we're gonna add a new parameter called input key, maybe? Input key int, default value 0. No default value. Refactor. Okay. It didn't. It put it at the end. No, please God, no. Please no. This has got to come up here. Okay, so our input key int, right? And then I think what we're gonna do is we're just gonna say input key is equal to f.key and just return it every time. I suppose instead of doing that, it's a little awkward. Let's make it so that we'll just return it directly. So we'll say f.input key, f.key. And this is going to be, because this is why, right? We don't need to, there's no need to actually return something in the error case. It just looks weird. Don't love it. Here we're going to have 0 as well. And then the only important case, I guess, is this guy, where we're going to return f dot key, right? This is the truly interesting case. Music's getting a little loud. Turn it down a little bit. Okay. Now I can think again. So we return our key, and then when we actually call this thing, we can use it, which is going to be sweet. Essentially what we do here is we've got to now get this ret keys array going. And the way that that's going to work is what? What is the way that that's going to work? I mean, I suppose we just want to initialize this thing first of all. Okay, so here's our key. And what do we do with our KV? We say set next KV. I think what we should do. What should we do? I think what we do is we're going to edit. We're going to add a new parameter here. Next key. We're going to need to edit some of these variables because they're confusing, but we're going to just say for now, next key is the opaque key identifier of the span that originally generated the data that the next KV that generated the next the data in next KV. How about that? So then when we go to say finalize row or whatever, state finalize row, right? In state finalize row, what we're going to do is what? When is this thing ever used, huh? Is this thing not usable? Is this thing just not used? Or is it used? Oh, it's definitely used. It's definitely used, just not like in a really clear way. Okay, I'm gonna ignore that. So, ID call. I mean, I suppose we can actually use this same style. So what we're gonna say is, yeah, we're gonna have a new thing called eCall, which is really confusing, right? I suppose we could call it a call data dot int64s, right? Is this going to be an int64s? Whatever. Let's just make it a slice of int, whatever. Okay, so eCall is a list of opaque key identifiers that generated each of the rows in the output batch. Really want to play with it? Yeah, cool. You should definitely tell your friends that they should support it too. I love that idea. And what do you know of things that are missing, or it's just you guys haven't gotten around to it? So I think here we're going to say rf.machine.key, next key. Oh, we can't do that. So we'll just say rf.machine.next key is equal to key. Unless we could also just use set next kv to do that. How many places is this called? I think that would be more elegant, right? Yeah. Customers requesting other databases. Word up. Word up. Okay. So now that that part is all good to go. Well, this needs to be changed, I suppose. So this should be called span key or something. Span key, maybe. Let's just call this next span key. So confusing. Who knows? Okay, so now that that's done, we can return ret keys when we need to. Oh, wait. Inside of finalize row, we've got to do some other stuff. Finalize row. So here we're going to say rf.machine.keyCall. This should be called span key call of rf.machine.rowIDX is equal to rf.cur machine.cur next span key. Cool. And then the other crucial thing is that we've got to initialize this thing. So I guess we can just do it in a init or something. I don't know. I feel like there's a smarter way to do this, but where do we have some kind of max output size business? This guy, right? When do we set up this guy? Reset, maybe reallocate. Min desired capacity. Okay, we'll do it right here. And we're going to put it to do Jordan account for the span key column. rf.machine.span key call is equal to make int min desired capacity. All right. Not seek prefix. Key span call. Span key call. Span key call. Okay. Okay. So then the last thing to do here is when we return a batch. Well, we don't even need to do that. It's probably fine. It is probably fine. I think we are good to go. I think we are good to go. And we call next batch. Call next batch, then
The data bank's too big. I have to narrow down the search. How are you gonna do that? I guess
span keys. Oh yeah, now this is getting crazy. I think in this case we don't need it. But in this other case, we certainly do need it. Well, we actually don't even need it in this case. But one day we will need it in our lookup join operator. One day we'll need it in our lookup join operator. And I think that, truth be told, this might be a reasonable place to stop. Let me see. Make build. So we're definitely not going to get to the whole lookup join implementation today. I think this was good. I think this might teach us some stuff, and we might actually be able to even use it when we put the streamer in without too much further changes. But yeah, we're going to be stopping pretty soon. We were going to do a little short stream because I've got some stuff to do in a little bit. Having dinner with a friend. But yeah, this is, I feel like it's some good progress. We can do our first software and game development category raid, which is exciting since that's a new category on Twitch. But first, let's just see if things compile. If it doesn't quite compile, I'll fix that before I stop. Just to get it into a good state, you know? What is everybody doing for the long weekend, by the way? Any exciting plans? Sushi go around places, yeah? Like the conveyor belt things? That's cool. Are you in the West Coast or the East Coast? I've been to one of those on the West Coast, never on the East Coast, though. I feel like maybe they're not as East Coasty of a concept these days or something. Texas. Oh my gosh. I was not expecting that. They got sushi in Texas? I did not know that they had sushi in Texas. If I had to be completely honest, I did not think they would have sushi in Texas necessarily. Because you don't... Do you... They got everything in Texas, but it doesn't necessarily mean that it's good. Because you can't really fish in the Gulf, right? The Gulf is like not something where you don't really fish there, do you? You got to get it from elsewhere. But then obviously they've got sushi everywhere. You just ship it from elsewhere. What lives in this Gulf of Mexico? You've gone deep sea fishing? Oh, that's cool. It's pretty crazy. The Gulf of Mexico. It's so enclosed. It's really nuts. It's like the world's biggest bay. It's actually not as big of a bay as Hudson Bay. Hudson Bay is a much bigger bay. Much bigger bay. But not by much. It's about the same size. right? Hudson Bay is a little bigger. I don't know. I want to visit Hudson Bay one day. That's one of my dream destinations, even though there's probably not much there, to be honest. I just want to see it. Imagine, this is like the craziest place ever. So big. All these crazy lakes everywhere. North Canada. Who knows what's up here? Probably not much. Probably wilderness. Probably a lot of wilderness. But I would take just visiting here, honestly. This would be cool. GeoGuessr? I'm going to be so bad at GeoGuessr for sure. A lot of polar bears. Yeah, there's that new Cockroach Cloud free beta. So that's serverless. It's going to be soon non-beta. It's going to be soon non-beta, and it's going to be a full serverless SQL thing. It's going to be so exciting, you guys. I can't wait to talk about that when it comes out. It's going to be really cool. Moving to good old NYC. Nice, nice, nice. I'm a big NYC fan, obviously, having lived here basically my entire life, so I recommend it. I recommend it. It's a good place to live. But yeah, check out that Cockroach Cloud free beta. That's the serverless technology. You know? Okay, so we have a couple of little last things to fix here, but it's not a big deal. Gulf of Mexico is 1.5x size of Hudson Bay? What? How could that be true? How could that be true? Is there like a little area tool? I thought there was like a ruler. Where's that ruler at? Oh God. Google Maps. How? How does one use it? Right click? Oh. Measure distance. Checked on Wolfram Alpha. Oh, interesting. Okay, measure distance from here to here. So 939 miles. So about 1,000 miles times about...
Too big. I have to narrow down the search. How are you going to do that? By guessing.
1,000 by 500 miles. Okay, let's check on Wolfram Alpha. This is obviously sketchy. But is this sketchy too? Is Wolfram Alpha also sketchy? What? Okay, that is really confusing. Do you think it's just because of... Do you think it's the map projection that's confusing me? Okay, what if we turn this into the globe? What if we turn this into the globe view? How do I get that globe view? I thought there used to be a way to get the globe inside of Google Maps, but I could be wrong. Okay. So here we got the Gulf of Mexico. Then we scroll up, and then we got Hudson Bay. Up. You are absolutely right. Look at that. The Gulf of Mexico is really big when you look at it straight on. And when you go up here, Hudson Bay is really not quite as big. Okay, well, TIL. TIL. Fascinating. Cool. Very, very cool stuff. Okay, so let's fix this thing real quick here. So we need to fix the interface of this guy. It's got to have... We've got to return something called the KV batch fetcher response. And here we're going to return KV batch fetcher response like this. And otherwise, we're going to return KV batch fetcher response with more KVs true. KVs, f dot KVs of this thing. Wait, why is there an if? There is no if. Nil. Nil. Okay. Try again. This looks broken, but I don't think it's relevant. Oh yeah, I've seen this, the true size thing. It is very neat. If only I could put Hudson Bay, but I can't. Yeah, this is really nifty. Yeah, if you put the... Wow, man. Definitely crazy, these map projections, huh? Yeah, it's fun to play around with, for sure. Okay, so here we've got to fix this guy to be not broken as well. KV batch fetch a response. Okay, and then I think we can just... I don't know what's wrong with this bin data thing, actually. What if I just delete it? Okay, cool. Well, I think this is good to go then. Obviously, we haven't added tests. Obviously, we haven't really done anything end-to-end, but that's kind of the main thing I wanted to start with. Let's just make a quick commit. Git add 1 through 8, git commit. So this is going to be SQL initial attempt at adding opaque keys to fetcher. I'll just add opaque keys to fetcher. The upcoming streamer interface will expect callers to pass in opaque integer keys to keep track of which response corresponds to which input. This commit plumbs these opaque keys in via the fetcher stack in preparation. Release note, none. Git push you mine. And let's go ahead and mark this as a draft, which I always forget how to do. It's over here. Okay. Okay, so that's that. I think it's time to wrap it up though, you guys. Let me find somebody to raid real quick here. Let's take a look at this new software and game development directory. Let's see what it's looking like. We got Jamie Pine Live, who's building sub.2. We got Bash Bunny. We got Vimlark. This is cool. It's only the tech people. This is exactly what everyone was hoping for. Here's Griffing. Here's me. Here's Pocket Watch. R stats. Building apps with R, eh? Who haven't we rated in a while? Oh, we gotta rate a compiler stream, 100%, right? Oh, it's not online anymore though. That's too bad. Let's refresh to make sure we've got. Yeah, they got rid of the ducks, but they pushed the ducks into a different. They left them in the science and technology category, and they made a new one just for the programmers. So who? It's too bad. I wanted to raid that compilers guy. That would have been cool. Falling Sand game. That's the other thing. It would be technically nice to have a separate category for the game people versus the non-game people, but I guess you can't hope for everything, right? Oh, it's so nice and small. Oh, this is cool. I'm a big fan of this change. Let's go ahead and raid this person if they have a cam and they're talking.
You can correct me if I'm wrong, right? That's what we do on the internet. We say something.
But they're not really doing R. I thought they were doing R. R is kind of cool.
So we're gonna open 24C.
Okay, they're not really doing R. They're not really doing R.
Doesn't make sense. I've used it.
This person's doing coding problems.
So yeah, again, if people want to join the room,
It's pretty popular to do coding problems. Bash Bunny does Go development. I usually like to raid people with lower viewers just because it's sort of more exciting. But yeah, maybe we should raid Bash Bunny. I feel like they're a pretty popular creator. I should probably network, right? Okay. All right, everybody. We're going to raid Bash Bunny. We're going to be networking. But anyway, this has been really fun. Thanks, guys, for all hanging out. I hope you have a great weekend. I hope you have a great long weekend. Do something fun. Go outside. Enjoy yourself. Enjoy your day. And yeah, you know, I'll just see you guys next time. Wait, I didn't click the raid button yet. I did my little outro without being ready. But thanks for hanging out, y'all. Thank you for hanging out. I'll see you guys next Friday. That's all I have to say. I wasted my outro. I'll see you guys next Friday. Okay, bye-bye.